So the first one is loss of torque. And I just wanted to show this video. So how this works. It's I mean, it's a classic. You might have seen it already. Can you tell me if you've seen it? Has someone seen this video already? Yeah, you have. Anyone else? No. So this is a wind turbine that's like overspeeding. You know, like things went wrong. Like we're gonna talk about what went wrong. Things went wrong, and it overspeeds, and then, well, you know, it's like the blades hit the tower and everything like collapses. Okay. I mean, I'll just show it quickly again. What happens here is that one of the blades hits the tower, and then, you know, there's like an imbalance in the masses of the rotor, and then, like, you know, everything goes downhill from there. So this video is very interesting because it's if you analyze what happened there, it tells you a lot about wind turbines. So yeah, so that's why I wanted to talk about this one. I'm gonna show you I'm gonna use a version that's not online just yet. So that's why, you know, if you download the software, you won't have to, you know, to deal with this like ugly piece of code. It's just because I wanted to show you from the latest version. Okay. So this is our software. If you download it, you will get exactly this, and you have like a few default models that you can use. Okay. For the analysis or for studying the case that I just showed you now, I'm going to use this model, which is it's just an onshore wind turbine. So a wind turbine that's built on land. I mean, this is not a tutorial. Okay, so, you know, I'm just going to be doing things. If you don't get what I'm doing, just, you know, you can always ask. You can you know, feel free to interrupt, and we can have this as a conversation. But just what's interesting here is to see kind of the results. Okay. But so the first thing that I want to tell you is that there's two things that failed in this video that we saw. One is that there was no brake applied on the rotor. So the rotor, you know, like the three blades that were spinning, there was no brake applied there. And the second one is that the blades were supposed to have pitched to slow down the wind turbine. I'm going to show you what the pitch is, okay? Just to make it clear. So if I come here and I say that I want to set the pitch scheme to live. Okay, so now have a look at the blades, and I'm going to show you what pitching a blade means. Okay, so can you see how the blades are rotating around their own axis? Okay, so that's what it means when a blade is pitching. Can I ask you? So I don't really know how much people know here about wind turbines and stuff. Who knew? Like, do you know what this is? Did you know what pitching the blades is, for example? No, not really. Okay, cool. So then I guess it's good that I explained it. So this is one thing that didn't work, and the other one, as I said, is that there was nothing kind of slowing down. There was no brake applied on the shaft here. Okay, so this is rotating, and this. In this case, something was supposed to be like stopping it, and we'll have a look at what this was. So what I want to show you here is, let's see, the aerodynamic torque and the generator torque. Okay, so that is this one here. So yeah, I'm going to put both of them together. Okay, now I start my simulation. So there's two curves right now here on the right of the screen. Okay. The blue curve is the torque that is applied by the wind onto the main shaft of my wind turbine. Okay. So the blue curve here is basically the sum of all these, you know, little vectors here, all these individual loads times the arm to the center of the hub. But so the blue curve is what is trying to spin my wind turbine. Okay, so the blue curve is what we want, is what is making my wind turbine rotate, and is the aerodynamic torque. The red one is the generator torque, and this one is acting in the opposite direction. So it's kind of trying to slow the wind turbine down. And that is what, you know, that's where the power comes from. So, you know, you have like, well, you could imagine that you put like a big resistive load, and then that's kind of producing a torque on this, like on this spinning contraption, and that's what's breaking the wind turbine. So, once the wind turbine is kind of on a stable state, you have that both are roughly equal. So you have the aerodynamic torque and the generator torque that are more or less equal. Does this make sense? More or less. Okay, cool. So I'm going to show you a few more things. One is the rotational speed. So the RPM, how fast the rotor is turning. Another one is going to be the tip deflection. So this is on this blade, the blade that's lit up now. The tip deflection out of plane is how far this bead here is moving away from the rotor plane. The rotor plane is the planes as defined by the three blades. So here, what you're seeing is how far it's moving backwards, kind of. Okay. And again, because this is all finite element software, I also want to have a look into what's happening inside the blades. So we're going to open an element here. Okay, this one, for example, and then I'm adding a sensor, and we're going to look at the axial force. So the axial force is, how much you're kind of pulling on the blade or pushing the blade. Okay. And I'm going to start my simulation again. Okay, so now what we have here is the rotational speed, which is now constant. It's constant because both my torques are the same. So basic seconds Newton law, you have sum of forces is mass times acceleration. Sum of torques is rotational inertia times rotational acceleration. So if the sum of the torques is 0, then the acceleration is 0. So that's why the rotation speed is constant. This is the tip deflection. So the blade is moving a bit backwards, so the tip is a little bit backwards. And then this is the axial force. What's interesting here, so let's see, we're looking at this blade here. What's interesting here is that the axial force is the maximum when the blade is pointing downwards, right? Because you have, so what's creating this force right now is the fact that the blade is rotating, so it's centrifugal effects, and it's also gravity. So when the blade is pointing downwards, the gravity is pulling it, is increasing that force, but when it's pointing upwards, you don't have that. So that's what you see here. Okay, all clear so far? Cool. So let's see. So now we're going to try to reproduce what happened in that video that I showed you. And for that, I can say that I suddenly have a loss of torque. So at 10 seconds, we're going to lose the generator torque. Okay, so I just start my simulation again. And there's a little bit of transience, so it takes a bit of time to kind of reach the same speeds. The same speed that we had before. And now at 10 seconds, we lose the torque. So this red curve here is gonna go down. What's gonna happen? Any ideas? So yeah, basically. So yeah, I mean, spot on. Obviously, again, Newton's second law, right? So suddenly you have a torque, you don't have anything stopping it. So, what you can see now is we get the RPM, so the rotational speed that is increasing a lot. And as you were saying, we get the deflection, which is here, which is also increasing. And the axial force is also increasing. And if I look here, I mean, we can zoom in a little bit. And you can see that now the blade is kind of getting really close to, it's getting really close to the tower. We're not there, we're not at the states of the video yet, because this is a relatively, low wind speed. So we're not hitting the tower. I could increase the wind speeds, and then eventually you would see that. I think probably if I'm at even 50 meters per second, yeah, I think you can already see that here we're hitting the tower. There's nothing. If it hits the tower, there's nothing in the software. Nothing happens. It just kind of keeps going. So you would have to check yourself that it's not hitting. But yeah, so that is exactly what happens in this video. Is that suddenly the generator torque was lost, and then the wind turbine just speeds up. Yeah. Sorry? Yeah, yes, this is so yeah, the question for the people online, the question is this happening in real time? And the answer is yes. Yeah, this is real time. So when I increase the speed now, the wind speed, I did increase it in real time. Cool. So now we're gonna so this is what happened in the video, and that should not happen. From checking Wikipedia, which didn't have many sources, so I'm not sure how much we can trust that. But talking about this event that I showed you on the video, they were saying that the error was that a gear inside the generator, or inside the gearbox, broke, and then nothing was connecting the generator to this shaft that is holding the blades. So because of that, nothing was stopping it. So essentially, we just lost the torque, and then you see what happened here. There was a second failure, which is that the blades did not pitch, and I'm going to show you what should have happened if the blades had pitched. So for that, I can use a Python script, and I have it here. Controller pitch to feather. And then I think I have to set it. Yeah, exactly. So the pitch should come from Python. Cool. I know it's going to be the same thing. It's a little bit slow. I'm not sure why. I think it doesn't like when I share my screen. So right now it's slower than usual. But right now what's going to happen is that at 10 seconds, we are both going to lose a generator torque as before, but we're also going to be pitching the blades. Okay, I know you can see. So again, we're losing the torque, but now the blades start pitching. It's a bit messy, so I'm just going to remove the visualization of the loads. But now what you can see, it's a completely different picture. So now the tip of the blade is not like getting close to the tower anymore. So now you can see that it even became negative, which means that it moves in the other direction. The rotational speed, which you have here, is actually decreasing back to 0, because now the blades are, they're in a position where they're not really capturing the wind anymore. So now this is like an emergency shutdown, and now the blades are supposed to keep the wind turbine from spinning, basically. Okay, so this was the second failure. This is something that should have happened, but that did not happen. And I don't know why. I don't think that this Wikipedia page had an explanation for that. Cool. So yeah, that was this one failure event. Do you have any questions about this? I can move to the next one.